Welcome to my talk about QPA. Hope you had a pleasant day so far. I know at this time of day it's hard to keep awake, but try to keep you awake. Although I have a small warning, it's a little bit dry area we're talking about, so don't expect much wonders or much fancy stuff, but a little bit I'm going to show you. So we're talking about QPA, Qt Platform Abstraction. It's a new Qt port. It's also the successor for Qt for Embedded Linux. And it eventually will be the one to rule them all. My goal in this talk is that you understand this new Qt port, what it is, what interfaces there are, what possibilities you have to use it and to integrate it in your systems. This is a little bit covered in my outline. So there are different angles to it. You always saw that on the first slide. First, going to tell you where it comes from. So what's its predecessor? The old story, I call it that, because it's deprecated more or less. Then I'm going to show you a little bit the overview, the architecture of QPA, what's more or less the same as the old one. And then we're going to talk about important classes. So I'm not covering all classes, which you might eventually have to touch, but like the classes which you have to touch from the first interface you're going to see. And in the end, we're going to talk about the rule them all thingy. We're going to talk about the future, Qt 5 basically. But first about me, why do I stand here? I graduated computer science 2009. Small university not far from Munich. I used Qt heavily during my studies for basically all practical exercises, both internships and my diploma thesis. After graduating, I became a professional service engineer with Nokia here in Munich. We are helping customers to succeed with their projects. It's mainly embedded projects, devices, products. Our two main businesses, our two main areas of working is the IVI sector in vehicle infotainment, so Qt in your car, and the STB, set-top box business, so Qt in your television. Both industries are used to have their own proprietary, they call it layer managers. Software engineers would call it window managers or something like that, or surface managers. They call it layer managers. They used to be silicon-based. Nowadays, they're becoming more and more software-based, but they still tend to stick to the proprietary API thingy. So if you want to use Qt there, you have to write your own Qt port, basically. And there is something around for a while now. So the old story, going to talk about soon. In my free time, I'm glad to go out. As I told you, I'm Bavarian, so I like beer, obviously. I like traveling where my job comes in handy because our customers are all over the world. And as any good nerd, I like video games. So the old story. I want a little bit to understand my audience. Who of you knows Qt for Embedded Linux? Okay, you're not totally wrong here. Who of you who had just the hands up had do the integration job, cross-compiling, choosing the right plugin, and all that kind of stuff? Okay, you're definitely right here. And who of you have actually written or contributed to a graphics plugin? Okay, at least 3. I haven't really expected that. Have you enjoyed it? Do you like the API? Be honest? Yes? Okay, then you're different than me. No, I meant the old system. I meant graphics plugins for QWS. Do you like that? Okay. There you go. Sorry for the unclear question. Yes, the old system, it has different names. It's named Qt for Embedded Linux, One of its parts is QWS, but QWS is also kind of the name for it. And another name which you shouldn't use anymore, it's Qtopia Core. What it is, it's a plugin-based Qt port designed to run on virtually every POSIX system. So you might know that, so this is the graphics, this is the architecture overview, and Qt Core is purely operating system dependent. So there's a POSIX Qt Core, right? And Qt GUI needs more than that. And in the Qt for Embedded Linux case, more than just the operating system is provided by the graphics plugin. And a very important part of it is this little guy here, the QWS, Qt Windowing System. This guy takes care about bringing all the different processes together and bring all the windows they provide and they use onto the screen. All that the screen here is provided by Qt. It's part of the Qt for Embedded Linux port. All that's little is provided by the operating system, the platform. It's only provided by the silicon vendor or by your Linux distribution or something like that. And this is the one you have to write, or which is maybe already written. There are a lot of already written ones, but if you have, for example, a proprietary system, this is the one you have to write, or whatever, or whoever. There are a lot of good things about it, actually. It was used a lot in the embedded sector because it has a lot of benefits. This slide was way longer when I first made this slide because there are a lot of good things about it, but I don't want to brag too much about the old system. It has full multi-window and multi-process support. It already comes with the necessary remote process communication protocols and all the implementations for that. All the code for that, it comes with it. It has nearly no dependencies, fast DevDays and so on and so on. So it has its use cases, but nowadays the game is a little bit changing. The environments are a little bit changing. More and more embedded devices get very powerful graphics acceleration, and other things change over the time, and more the cons came along. The first two are the most important ones for the actual product. Qt Windowing System is a must-have. So why is this a problem? So Qt Windowing System is a windowing handler, or window manager, or layer manager. There are different terms for that kind of systems. So it handles surfaces. And if you're in a proprietary layer manager, like in the set-top box or in your car, then it's kind of unusual or unnatural to put yet another windowing system on top of that. So it's kind of a windowing system on a windowing system. That's not very natural. It's not very performant. It brings problems with it. It's not a really big issue, but it makes troubles all the time, or a lot of troubles. It can't really handle OpenGL. So there were a lot of blog posts, a lot of rumor, and a lot of things going on that now QWS can handle OpenGL, and 2 months later, now it can handle OpenGL. But they all had limitations and all had problems and were for specific hardware, or did only support one context, or all kinds of limitations. I asked you why if you like the QWS API. For me, it's a very complex API. It has a lot of anti-patterns. If you don't know it, to get into the API and how it works is kind of horrible. So for me, it was one of the worst weeks in my life when I had to write my first QWS plugin. For instance, or the most extreme example is that if you have server-client architecture, so you have a server, which is the windowing server, the Qt windowing system, and you have some clients, you have to have like the same representation on both sides, right? He has to know what a window is, and the client has to know what a window is as well. What some smart guy thought was a good idea is using the same class for that. And the only thing that decides if it's a client representation or server representation is what constructor is called. And then you have to remember that, and like in a Boolean or something. And then if Qt asks you what the size is, then you have like an if statement at the beginning, am I the server? And then you go one way or the other way. So it's mixing all different code into the same class. And that's one of the things which make it very complex to understand what's going on and to debug and to see how to implement it. And I mean, there are more anti-patterns and there are more strange things there in the API. The documentation is limited. The only way I could get through that week, or 2 weeks actually, was because a colleague of mine was sitting in the next room who has written several graphics plugins. And I was there like, I don't know, 100 times. The documentation is limited. Lots of server client code. It's related to the anti-pattern thing. So in the end, what you going to, or what the guys in the Oslo office realized, I think actually it came originally from Brisbane, the abstraction is at the wrong level, or it's the wrong type of abstraction. So QPA was invented. QPA stands for Qt Platform Abstraction. Actually, the short version, QPA, was there before anybody knew what it should mean. It's kind of funny, and could mean anything. It's a new and independent Qt port, so it doesn't share anything with the old QWS port, besides its architecture a little bit, but code-wise it doesn't share anything. It's also plugin-based as the old one, but it has a totally new set of APIs. There's one or two tiny little things they share, but that's not important. It's a new set of APIs. So this is again the old architecture. I show you, just put that there so you see the difference. The most important difference is this little guy is going away in the new architecture. This is really by far the most important difference between the plugins. QPA does not have any windowing system code in it. It's kind of not very important, but the new one called platform plugins, the old one are called graphics plugins. And the third difference is that the usual use cases are different. But you can more or less get both run on both use cases, more or less, with limitations, of course. So yes, QPA. Oh, the differences, right. So both are plugin-based Qt ports. So it's a Qt port where Qt GUI does not connect to a windowing system or to a graphics API like DirectFB or Linux frame buffer or something like that. But it's a plugin-based Qt port where the plugin defines where it connects to. The new API is way cleaner, it's easier, it's smaller. The old one is very complex, very harmful, very, terrible. So I told you the main difference between the two is the one comes with a windowing system, the other one not, meaning that QPA can interact with a windowing system, but it does not provide one. So it depends on external windowing systems. If you don't have one, you will not have multiple processes. You will only have one window, one process. It's okay for a lot of use cases, but just that you know. If you don't have a windowing system, you don't need an RPC protocol. So in QWS, you need one. It's built in. QPA depends on something external, some external library, libx11, libwayland client, or something like that. QWS is not really OpenGL aware. You can get something running, some with a lot of limitations. QPA is fully OpenGL aware and prepared to have OpenGL setups. Who of you have seen that interface so far? Like 4? Huh? Not bad? So this is the entry point for the plugin. It's a factory class. It's, as you see, abstract. In your plugin, you have to implement one of those. And this is mainly defining the behavior and the setup, the architecture of your plugin. Again, the entry point, factory class, main definition of architecture of your plugin. So this is a little bit how it looks like. So again, the same color scheme as before. Green is what's in Qt already. This turquoise is what you have to implement. And yeah, not that fast. So Qt needs for certain things some backup, some backend. So for example, a QPX map needs a place to store its data. A Q font needs a pixel size, and then at the end needs its glyph to actually render. A Q widget always needs a surface, and if it's a top-level widget, so a window, then it needs a window. And as I said, Qt Platform Integration is a factory class. So it generates, it factorizes things. This is here like mentioned or like symbolized by this little pink one. This little pink one are all the different things which come out of the factory class. And depending on what type of pink thing, it might ask your platform, or it might ask your operating system, or it might ask even Qt back, and then there's a default implementation in Qt or something like that. Important thing is, it might or might not ask your platform. So this purple things are the integrator, the integration into your platform, like X11 or Wayland or DirectFP or whatever. So now we're going to talk about all the different all the different pink objects you can generate, or you have to generate. We're starting from the big one and then go smaller. So the biggest one, obviously, is the screen, your monitor, your display. It's represented by the Qt Platform screen. What it mainly does is initializing things. So it turns on your monitor, more or less. It also queries properties from, not your monitor, probably your graphics card, but like how big is the screen? What pixel resolution does it have? What physical resolution, what physical size does it have? What pixel format does it support? And so on. Obviously there can be more than one monitor, right? More than one display. So there can also be more than one Qt Platform screen. Yeah. Qt Platform, so now we're going to talk about two classes which are a little bit difficult to distinguish. First, again, the big one, the Qt Platform window. It's the representation of the window itself, not about the content of the window. It's not the surface of the window, it's the window. So if you think about pixels, you could think it's the border of the window. I mean, you don't have to have a border, right? But kind of, it's more like what's around the window and what's the integration into a windowing system regarding window. Not about the content, not about the surface. So what it has as main functions is set geometry, so a size and a position, because a window can have a position, right? Raise lower, so you have windows behind each other, so you can move them around, forward and back. And the window title, which is maybe important, maybe not, depending on the use case. And many more, but that's the most important, or the ones you most easily understand what's the use case of this class. The other one is QWindow Surface. QWindow Surface is about the surface or the content, so the inner parts of the window. And it's mainly for painting and flushing whatever you painted to the screen. It does not have, again, don't want to totally lie, it has a geometry, but in reality it only has a size. So it has no position. It's always at position 0, 0. Yeah. You can see there are two pure virtual functions you have to implement if you implement your own Windows surface, and you have to implement your own Windows surface. There is no default implementation. So either you steal one from another plugin or you implement your own. But within Qt, there is no default implementation. Unlike the platform window, there is a default implementation which basically does nothing. So if on your platform you don't care about Windows, you don't want to raise, lower, set geometry, just don't implement it and use the default implementation. Okay, back a little bit smaller. A QPixmap needs a place to store its data. And that's QPixmap data. And you normally don't write your own Pixmap data, but the only thing you do is in platform integration, the factory class, you return what you think or what fits your use case. So it's either raster, OpenGL, so QGL Pixmap data, or it's splittable, which is more or less DirectFB or other things, but I don't want to get into detail there. Yes. Next one, Qt Platform Font Database. It's an interface to your platform font database. Pretty obvious. It creates and returns QPateengine, more or less. Again, you usually don't implement those. You just choose what you think fits your platform best. There are two implementations which should cover a lot. QFontConfig database and QBasic Unix font database. Both use free type. QFontConfig database uses FontConfig to choose the right font and parameters and get some informations, and then uses libfree type. So just try both, basically, most cases. QFontConfig database made a little bit trouble in my setup first when I created this presentation and tried a few things, because if you don't set a font, it chooses some strange, unusable font which cannot be resized and has only one size and is non-antialized, and it was quite ugly, so you have to experiment a little bit. There is the generic Unix font database, which chooses QFontConfig database if Qt was built with FontConfig enabled. Was that kind of clear? If you build Qt, and it will auto-check if there is FontConfig, and if this is passing, if this is enabled FontConfig, then the lower one, Qt generic Unix font database, will choose QFontConfig database, and if not, if in the Qt config the FontConfig test failed and there is no QFontConfig, then it will use QBasic Unix font. QBasic Unix font database. Long, strange word. Yeah, that's basically about fonts.
Question?
Oh, yeah, sorry. If you have questions, just raise your hand. Thank you.
In the original Qt embedded, you can also use the precompiled font system of Qt.
I think that's still possible.
Can you repeat the question?
In the original Qt embedded, you can also use the precompiled fonts of Qt. Can you still use those in QPA?
So in the current implementation, I think not. So in the implementation of those two, not. But the precompiled font config, the font engine which uses the precompiled font is still there. So I haven't tried it yet, but I would assume that you just have to write your own Qt Platform font config database. Qt Platform config. Oh God. Qt Platform font database, and return the font database which the font engine that uses the precompiled fonts. Yes?
My question is, I guess you will implement some kind of Windows font database on Windows when it's QPA enabled?
I'm not a Windows guy, so I haven't looked it up. I'm sorry. I'm pretty sure they have something. I'm not sure if it's going to be available in Qt4 though.
My question is basically, can I not use that? And is there a way for like to only change the font engine on a platform? Like I don't want to have the Windows font rendering stuff. I want free type on Windows.
So, okay. Yeah. So in Qt4, there is currently no Windows backend. In Qt5, there will be one, and you can just like copy it and return your platform font database. If you get QBasic Unix font database on Windows Building, which you shouldn't based on the name, but I guess you will get it running. Maybe you have to change it a little bit, but I'm pretty sure you can return whatever you want. And I mean, it's about getting it running, getting it compiling, and yes, you can return different things if you write your own Windows plugin, which is like you copy the one which we provide in Qt5 and just change the font thing. Okay. So far we talked about the way up. So from Qt to your platform integration and then to the operating system or the platform or whatever. But what's about the other way around? What if your platform has some information for you, like a window got entered? So I don't know, someone pressed Alt-Tab or moved the mouse and you have sloppy focus or whatever, and a window got entered, a window got focus. This is not covered by Qt Platform integration, but this is covered by Qt Windows System Interface, which is a class with a lot of static functions, thread-safe static functions. That's very important. You don't have to care about thread issues here. And he will tell the appropriate Qt class what to do or trigger the right event, trigger the right whatever, system handler or whatever. So again, a lot of static thread-safe functions. And this list pretty much covers everything. So mouse, you have obviously move and click and everything. You have keyboard events, you have touch events. You have different window events, close and to leave activated, geometry changed, and some functions, some handlers for screen changes. So, for example, in your notebook, if you, I don't know, plug in an external monitor, then the count change you would have to call. Yes. So this is used by your plugin, but there is an additional other mechanism or plugin type which also uses that heavily, or has to use that heavily. It's called generic plugins. They are in the source code in plugins generic. All you have to implement is like you have to subclass QObject. They don't do anything on its own. So they do nothing on its own. So what are they good for if they don't do nothing? So what you can use is, again, the QWindow system interface, and just drop some event or something which happened. And this is, in most use cases, or the original use cases, were input plugins. So mouse, keyboard, touch. Now you might ask, why isn't that in your platform plugin, right? Because it's generic. It's a plugin which is not platform specific. So if, for example, Linux input has nothing to do with your platform. It's just Linux input, which is on every Linux system the same thing. So it's uncoupled from your platform. And for those types of plugins, you can write a generic plugin, or you can use a generic plugin. There is implementations for Linux input and TSLib, so touchscreens. And yes, you can just use them. You build them, install them, and if you want to activate them, you have to do a startup minus plugin and then the name. You can look up in the code, basically. It's Linux input mouse or Linux input keyboard, or I forgot the TS, the touchscreen one. But you can look that up in the source code quite easily. It's obvious how they're named. That's for the dry stuff. We have enough about that. Let's go to a little bit more funny thing, the demos and the code. The first demo you already saw. My presentation is actually running on a QPA build on X11. So as parameter, not ignore that a little bit, it's just enabling, it's just application parameter I just added. But platform xlib enables xlib. We can also try another one which enables OpenShell by default. It runs the same. But in that case, my application hasn't enabled OpenShell, but this plugin has default OpenShell context thingy. There's XCB. XCB is an alternative to xlib, which is synchronous. Yeah, so it's just another xlib implementation, more or less. I haven't enabled OpenShell now, so it's slow. But enabling OpenShell will solve that problem. It's obviously not as perfect as the other one because fullscreen hasn't like put itself on top of the panel, and it has some re-rendering problems. So the thing with plugins in Qt 4, they are not perfect, especially the X ones, because they don't matter very much, because there is a real X11 port. So why would you invest hours and hours in the Qt 4 port, plugin port, if you already have your perfect X11 port? It will be different in Qt 5, but more to that later. I have another plugin, which is called Minimal. Let me just delete something before we. No. It's right now? Yeah. Let me just delete the output from the last time. Before we going to execute it, I'm going to explain and show you the minimal plugin. Minimal again. Integration. Don't look at this stuff at the beginning. This is more or less the same interface or the same text you saw in my presentation about the platform integration, but it's a subclass of platform integration. So it's an actual implementation, not just the interface. The minimal plugin is supposed to be, or its use case or its purpose is to show the minimal possible thing you can do without having any dependencies whatsoever, except Qt, of course, or proper Qt build. So if you don't have any dependencies, if you don't have a platform, what can you do? You don't get pixels to the screen for free. So what this plugin does is at the end, it writes the pixels onto the disk, so it saves the images. Let's take a look at the implementation. If you're going to look that up on your own, this is not in there. I added that so I get the proper output because it returns another, it returns the default implementation of Qt Platform font database, which has a tiny little font, and that's it. I think even it's one pre-rendered, I guess, or something. So I added that so my output will be more nice. QMinimal screen is one of the classes we will take a look at. It's not much in there. What you can remember is that. Oh, sorry. What you can remember is that you're going to see a problem later on because of that. It sets the depth for the pixels and so on. The naming is wrong here. It's not a member, but it's data of a member. So screens. I'm pressing F2 to get the definition. Screens is a list of Qt Platform screen. It fits that interface here, which you have to implement. In our case, we only have one screen with fixed size and everything. Has capabilities, not very important right now. So create pixmap data, we need, our pixmap needs a place to store its data, right? I told you there are already implementations for that. And because we don't want any dependencies whatsoever, we use the raster pixmap data because the raster painengine does not have any dependencies either. I told you that you can implement your own platform window, but you don't have to because there is a default implementation. That's what's returned here. So you still have to return something, but you just return the default implementation, the Qt Platform window itself. And I told you that you have to have a window surface. There's no way around. You can steal them from another plugin, but you have to have one. There is no default implementation. It's a class with pure virtual functions. And this is just the return for the font database we created in the constructor. You see, I used generic Unix font database because the results were better if I don't set a default font for the application. Remember, I told you that I had some problems with the font config. If I don't set a default font or I don't specify a font for the text I'm using, then I'm going to have a crappy font which is only one size and not anti-laced. So I used the generic Unix font database which just uses nice fonts. I'm not exactly sure why, but it's more or less a setup thing, how your setup, your Linux looks like. So, no, I don't want to run it now. We have to look more up. This is a very simple class, minimal screen. You have to implement it, but it's really not much. It just has some public members we set in the platform integration C++. See here, all the members I set, all the members are public, and we set them, and in the functions we have to implement, we just return them. So it's not much, it's not very important right now. Let's go to the important class, QMinimal window surface. You already saw that interface. Oh no, sorry, I removed that slide. So what you have to implement are these three. You have to return some kind of paint device. There are already implementations for that. Some of them are kind of done, some of them are not. We're going to see one which is not 100% implemented in the next plugin I'm going to show you. You have to implement flush and you have to implement resize. No, actually resize you don't have to implement, but never mind. Okay. Implementation. The paint device returns a member called QImage. QImage is QImage. What a surprise! And the interesting thing here is the flush. So what the flush is supposed to do is bring pixels onto the screen, right? But there is no screen. There's only a file system, and that's what we are going to use. We just generate some string, so you have like a follow thing. Each frame gets another name, and then we just save that. That's all we do. QImage has already a write file thing, which is called save. We give him a string, and that's it. What we haven't seen so far is how this is going to be created. That's here in the resize. So eventually, somebody will resize the surface so it gets a proper size. It eventually needs one. And in that case, so the important thing here is this line. That's really the only one you really need. It creates an QImage in the memory. So it will create the frame buffer more or less, or you can call it a frame buffer. And this frame buffer needs like a space, it needs a size, so a memory size. And this is calculated by the pixel size and the format. And that's all it does. Yeah, that's all it does, basically. And if we run it, we see 2 times the flush has been called. And I executed my presentation again, and what I see is not much. The problem with that is that if you might remember, maybe somebody already knows. Sorry, I shouldn't have typed already. But yes, the screen size. So why is the screen size a problem? Not because, I mean, here he doesn't care about the screen size, right? He doesn't limit it or something. There's no function there. But what I did, or in my presentation code, I used full screen. And full screen is going to ask the screen how big it is. If I do that again and look at the picture, that's there. It's exactly the size of the QML I implemented. So this is the minimal plugin, kind of useless, but a nice thing to first compile and see if your Qt is right. It's minimal, it doesn't have any dependencies. If this is working, then other things can work as well. The next simpler plugin I could imagine or I can find is the Kaka plugin. A colleague of mine, Senyk, wrote. It's also totally useless, but he wanted to learn how to implement the plugin. So he wrote this one, and it's really useless because it's ASCII art. So, sorry, it's too big. Again, yeah, if I would have run compits, I could have showed you in total, but it's somewhere there. It's just way too big. Yeah, totally useless, but a nice exercise. And a good example how easy you can do funny things or integrate into stuff, because he just did it to learn, and it was like 1 day or 2 days. And then another colleague like polished it, so in total it was like 3 or 4 days, and then the plugin was done. Yes. Very easy plugin. Also, it looks quite the same as the minimal plugin, so it does the same. It also renders in the QImage, and then at the flush, it doesn't save to the window. It doesn't save to the file system, but it tells libkaka to update this window. But I don't want to show you the code there. It's not worth it. Oh, I can show you that. So another one I want to show you, which is an important one, because a lot of other plugins more or less are based on that, is eGLFS. I can't show you because it will ruin my X11, and I don't want to restart it during my presentation. But I'm going to show you the code quickly. I think we have like 50 minutes time. Questions so far to the plugins I showed you, or anything else? I mean, we can QA now, and I show you more code as much as we have time. No? There are a question.
Is there a certain list of plugins that will be available for Qt 5?
Yeah, the list is in the source code.
Sorry?
I'm not sure which one will actually be supported. I guess that was the question, right? So what I can tell you that all the desktop plugins will be supported. So X11, macOS, Win32, so Windows. Wayland will be supported for sure. Maybe Directive-B, more or less. I'm not sure what the plans are there to move it to the community or not, but there is work going on the Directive-B plugin, so it will be there at least. The minimal. There are more, a lot more, but I'm not sure how much will be supported. Yeah.
What about the iOS port?
It will never be supported officially. Definitely not. The problem is that the iOS port has a lot of limitations regarding linking and deploying. So it can't be a full-fledged 100% everybody's happy with it port. It's impossible on that platform. So supporting it would be kind of not very straightforward. I mean, we don't even support the Android one, although the Android has the potential to be a 100% Qt port. There are more questions.
I have seen a lot about Windows surfaces and Pixmap and so on. What about the paint engine? How's that done? If it's neither Rust nor OpenGL?
You're going to see that in the eGLFS integration. If you return a paint device, that paint device defines what paint engine it uses with some returns. So it's a little bit complex, but in the end, the paint device defines what paint engine it uses. That's...
You said X11 is supported. Does this mean Xlib or XCB?
That's a very good question. I would assume XCB. I hope it's XCB.
I hope so too.
But I don't know. I mean, I know the guys from Oslo, and I would assume it's XCP. If it's going to fulfill and be able to write the full plugin and go the full way with the full Qt port and don't have any drawbacks, then I strongly suspect it's XCP.
I'm not sure if the question has been covered before. Is it possible to change the behavior of a plugin?
How do you mean that?
I don't know. If a plugin is missing some features or doesn't work correctly, I have to recompile it, do I? If I want to change it.
So, yes.
Yes, you have no chance to override the virtual functions again. No?
Yes, that's. I'm not sure if I got the question right, but that's.
Well, I just know some platforms which are just too buggy, and I have to work around every day. So I would have to recompile the whole plugin.
I think I know what you mean. What you could do is you cannot change that. That's loaded, and that's
Okay,
fixed. That's a singleton. That's a factory class. You cannot change those, but you can change what you return in those. So, if for some reason your OpenGL gives up, or something like that, you might be able to return a different platform window and a different window surface to change to a different paint engine or something like that. But if this guy gives up, then it's done.
Yeah, okay.
I'd like just to add something. Since the plugins are loaded dynamically using DLOpen, at least on Linux, DLOpen and DLSim, it's easy to override them using LD freeload or whatever.
Yeah, that's true. That's also a possible solution. And again, I mean, at runtime you define the plugin, right? So, however, wherever your program comes from, you can hack into DLOpen, or you can pass another platform property, or you request a platform property from your system, or something like that. So.
Is there a mechanism for customizing the behavior of the plugin, or do you just have to use environment variables if you want to make it tweakable?
I have to forgot to look that up. It's in the plugin interface itself. I haven't. Let me just check. Let's take the GLFS. So. These are parameters. You get, if you make minus platform, then the plugin, and then you do that one, double point thingy, then you can pass arguments, and they will be passed down to here. I haven't looked it up absolutely correctly, so I can show you right now because I'm not sure if I'm going to be able to actually do it. But yes, there's a functionality there.
What kind of hard work do I have to do to get a successful OpenGL support out of one of these plugins? Is there some nice default stuff?
Yeah. The common subset of EGL, of OpenGL 2 on the desktop and OpenGL on OpenGL yes to embedded, that common subset is used in the paint engine, and if you cover that, you can get it running. You need some kind of surface creation thingy so EGL in most cases. So if you're in embedded sector and you have EGL and OpenGL, yes, you're golden. But if you're only having that, then you don't have any feature or anyone taking care of sharing surfaces, which means you can only have a single window, single process setup, which is EGLFS, which is the plugin I'm going to show you if we have time left.
I don't know if that question is really specific to, or it's a general Qt question, not specific to embedded platform or anything. We've stumbled upon a problem when we try to sync to the vsync of the monitor in Qt. I think that's a general problem because I researched it and I found lots of questions and no answer.
Yeah.
So can you tell me something about it?
Not much. I had the problem as well. On some X11 setups, it's working quite good, VSync, but it's really the whole setup must fit together thing. I think on Windows it's working quite well on a Mac. In embedded sector, it's hard to get it running, and you have to have a proper driver which really syncs and really blocks on EGL swap. If you, for example, have an EGL setup, it's not easy, and I understand your pain.
So on our setup, it was specifically Linux virtual machine running on Windows. So probably it's more than one place where it doesn't work.
Yeah, I mean, you're surprised about that. Sorry. Yeah.
So while we're at the sync part, we would do that where in the flush function that would block until the sync is over.
In the flush function, you have to use some whatever your API provides, which is blocking to the VSync.
Okay, and then after the buffer flip or whatever, then you return from the flush function.
Or you have some double buffering thing or whatever you have in your setup, but the flush has to take care of it, more or less.
How can I port to QPA an application that runs two processes with two windows without the QWS now?
You have to choose something else. There is some things around. So DirectFB, for example, can you provide that? So DirectFB has a protocol and a mechanism to have multi-process setups. You will stumble over Fusion. It's a part or a side part of DirectFB, more or less. Or something else like Wayland. Or you choose the QWS port of the Qt for embedded Linux. So if you don't want to choose something else, go back to QWS.
What's the name of the QWS port on?
Qt for embedded Linux. QWS, sorry.
When there is a port to, now it's out of.
No. I mean, the old Qt for embedded Linux is still around.
Okay.
QPA is a new port. It's not a replacement. Okay. It's just a successor, and the old one is still around, at least in Qt 4. In Qt 5, if you want to have multiprocess, you have to have an external library providing that. So what I see most likely is Wayland. Hopefully. I mean, that's a good idea. We have 5 minutes left. I'm not going to show you the EGLFS code. The thing about EGLFS is it creates one context, and this one context is based or bind to one surface. This is full screen. That's the FS in EGLFS. And that's all it does. That's all it provides. One process, one window, which is full screen. Yes. Another port, which is if it's using OpenGL, is kind of based on each LFS, so I copied actually the code more or less, is the one I'm hope to show you now. I need HDMI now. It's that one. And the Android port. And this is a Qt Quick application using OpenGL. See, no file sync problems. What? What hardware is that? Galaxy S2. So quite powerful one. But it's also quite good. It's running very, very good. So I think I haven't compiled that one, at least not in that plugin, but for the old one, to show you that OpenGL is actually running, Quick 3D is also running. So the Android port is one of the ports which was actually only possible because of QPA. I mean, I could see, or from a technology perspective, it would be possible to write it in QWS, but I think no community member would be insane enough to actually do that for Android. I mean, as I said, the API is very complex, and it has a lot of limitations on modern devices. And on Android, you want eventually have OpenGL acceleration, and you will have limitations there as well. And yeah. Yeah. Yeah, that's it.